Alright guys, welcome to the Backyard Machine Shop. Well, we're back working on the Pratt and Whitney Lathe. I've actually been working on it for a few weeks, ever since I finished the X Mark, and maybe a little bit before then. But most of the stuff I was doing was little small stuff, fitting things, putting the compound together and the cross feed together, working on a taper attachment, things like that was just bolt on. It really wasn't video worthy. For about the past week, I've started working on the motor mount here, and I don't know if you remember, if you go back and watch the first video, I showed the motor mount, and I might include a couple pictures here. But the original mount here that somebody had made consisted of two rods, a counter shaft sitting on top of here that drove the spindle, and then the llama drive was up on top of the counter shaft. And it made this lathe, I would say, at least 7 foot tall. A lot of weight, suspended up high. It also was drilled and mounted to the back gear casting, and I didn't like that either. So I was beating my head. I wanted to do a line shaft, is actually what I wanted to do, but my shop's not really set up for that. I mean, I have 9 foot ceilings, 2x4 trusses. I probably could get one to work. You have to find all the hangers or either make the hangers. So luckily, back when I was rebuilding the llama drive that came with this motor, with this lathe, Mr. Charles Shandenfeld out of Jacksonville area, he donated a llama drive. He actually donated a whole LeBlanc lathe to me that was worn slap out, but the main purpose was the llama drive. And that allowed me, when that got here, it actually had this motor mount was used on that lathe. So I've racked my brain trying to figure out how to use it. Now this lathe is completely different, mainly because it has a relieving attachment. There's not a whole lot of area right here for a motor mount. You have a lot of things here you have to avoid and get it up high enough for it to work. But I decided to go ahead and go with this motor mount, and what I've done so far is I've moved this motor mount out, I think 2 1/4 inches. That gives me room all around. It spaces it out enough, and still keeps it to a point where I can adjust it and get it to drive over it. Next thing is I needed to consider was my relieving attachment. Now my relieving attachment, there's actually a gear that goes right here, and I'm not sure where it's sitting at right now. But this gear drives a shaft that comes back and drives the relieving attachment. Now, here's the relieving attachment, and it mounts back on the taper, and I'll back the camera up and show you that. But if it's got a little drive shaft with universal joints, and then we have a shaft here that actually mounts to this gear that drives it, and there's a shaft that I got to make that slides in and out of this shaft as it's working. So what the problem was, to keep this in order, either you had to keep the motor mount close into the lathe and go around the back of it, which the back gear didn't allow that. So the other option would have been to move it way out, which would have taken another 4 or 5 inches, and then you would have had an issue up here and a lot of weight on the back of the lathe and a couple other things. So that wasn't an option. So what I've decided to do, like I said, I've already mounted a plate. I've pushed my motor mount out 2 1/4 inches, and I'm going to take and basically bore through this mount in line with this bearing and drive that relieving attachment. So basically you just have the drive shaft coming through here. Now that drive shaft, as it's working, it has to articulate a little bit. It's according to how far the taper attachment goes back, or whether or not you have you're cutting a taper with the relieving attachment, and a few other issues. So my first consideration was to come in here and just make a jack shaft or a shaft mounted on bearings, push it through, and then have the universal out here going to the taper attachment. Well, the more I thought about it, I realized that by doing that, you're shortening this shaft up, and by doing that, you're eliminating a lot of your travel because of the shaft that has to ride in and out of this shaft. So if you shorten this shaft up, you have less travel through the lathe. So what I've decided to do is we're going to come in here and we're going to bore a hole. I think I can get a 2-inch hole in there, which is more than enough that I need to allow that shaft to work back and forth while it's working and keep the part strong and, you know, to mount. Even if I feel like it's not strong enough, I can come in here and reinforce this, box in this area, reinforce it, and it'll be fine. So what I've got here now is I've been working getting this set up now. This thing was fun. Whoever had put this part on the other lathe, apparently they just hand drilled a hole. So there's nothing consistent, measure them out. You basically have to mount it. I figured out a pattern, put it in a program, kind of took an average of everything, and mounted it up, drilled and tapped, made the part, and I hit 3 holes. One hole I'm maybe 10 thousandths off on. I'm gonna have to ream this one hole right here to get the bolt to come in with it, which I can do that later. And I'm not concerned with that. But anyway, we got it mounted, we got it good and rigid. We got nice clearance inside here on the back gear, and I'll bring it around and I'll show you some of that. Looking here, you can see how that mount, you know, you had to clear that, and so that's why we had to step it out. Come back around on this side. So coming around in here, you can see here there's the mount, and this is a piece of it was a piece of 2.5 inch aluminum, and I milled it down to 2 1/4. And I've got some pictures of it. I'm sorry I didn't show the process of doing it. I was just working and just got it done. It's got a little step up to avoid some bracketry back here, and let's zoom in on it. And you can see what I'm saying about it, pushing it out in 2 1/4 inches. And I don't have, like I said, all this other features in this lathe is hindering mounting this. So that's why I had to do the way I'm doing it. So all right guys, so like I said, we're going to come in here and we're going to locate a hole from this shaft. Let me see if I can find that shaft, and I'll show you what it does. Okay guys, so here's the shaft and the gear that goes in here, and basically this shaft comes through here, rides in that bearing, and then this gear slides on, and I'm not going to push it all the way on because I don't want to knock it back off. But anyway, that gear comes through, and the drive shaft I was showing you earlier actually attaches here, and that drives your relieving attachment. Okay, so let's put this key back in here. So what I've done to locate this, I'm going to set this up. Either I'm going to set this up on the Royceford drill press and drill through it, but more than likely we're going to set it up on the K&T and bolt it down and bore a hole through it. So the way I'm locating the hole, I got this bearing surface here in this bushing, and I turned or I didn't turn it, I actually had this. Good thing about this lathe is everything is pretty much nominal numbers. So I had a piece of 1 1/8, I think is what it is, rod, and it fits it perfect. And I took and I bored a hole for a little punch to slide into, just to keep it in there. And then we're going to push it through, and that's how we're locating that hole. We just tapped it with a hammer, and it give it a little tick mark in there. And when I get it out, I'll center punch it in, and we'll line it up and drill it. All right, guys. So I got you over here at the taper attachment, the relieving attachment. This is the taper attachment for the lathe, and there's some details in this lathe that need to be going over, and I'll go over them with you as we start doing things. But basically, this is your tongue that attaches to your cross feed that works in and out for the taper attachment. Now, here's the relieving attachment, and here's that shaft I'm talking about. And as that shaft will come in, like I said, from over there, you will have to, it rotates on a gear system just like a thread. It's the same, basically the same setup as threading. It's just that instead of you timing a thread, you're timing a relief. And as it turns, if you watch this little arm here, it moves in and out, okay? And so that gives you your relief in your part. Now, I'm going to bring you a little closer and let you see what I'm talking about. All right, so like I said, as that shaft is turning, if you watch, here's your shaft, and this is actually pulling your cross feed back and forth, okay? And there's cams that go in there. Those cams decide how far it goes in and out. There's gears that you got to calculate to when you want it to come in and out, and then a whole bunch of things that we got to get into later. But you see what I'm saying? All right. So let's do that again. It moves in and back. Okay. So like I said, this drive shaft drives that, and if I had taken and did what I said and made just a stub shaft that went in here, we would have lost several inches of travel along the ways there. So I didn't want to do that. So what we're going to do now, and like I said, a lot of this stuff is just in here temporary, like the back gear. I still got to pull it back out and do some things, but I just got it all sitting here where I can fit it. So we're going to take, so what we're going to do now is I'm going to take this motor mount back off of the lathe, and we're going to take it over and we're going to set it up either on the horizontal mill and drill and bore a hole in it, or we're going to set it up on the Royceford drill press and drill and bore a hole in it. So one way or the other, we're going to bore a hole in it, and I hadn't quite figured out what I wanted to do yet. So I'll be back when I get that set up. All right, guys, we got you over at the K&T horizontal. We've got the motor mount arm support, excuse me, bolted in, clamped down. We got an angle plate back here, and four clamps here holding it down. I've got like a 1-inch drill in, and we're going to try to punch that 1-inch drill through by itself without having to drill a pilot, and I think it'd be fine. Anyway, we got it set up on our mark back here, and what we're going to do is, like I said, we're going to drill it 1 inch. Now, I won't be able to get this 1 inch all the way through both sides, but when we start boring it, we may have to do one side completely and then come back and do the other side. We'll see. We don't have a whole lot of room, so I need to get a chuck key and tighten this drill chuck up. Our 1 inch didn't work too well. It wasn't cutting like I like, so I've dropped the drill size down. We're going to pop 2 holes in it, then we'll go back to the 1 inch. So I've reset up. I've actually moved the whole part over. It's something I wanted to do anyway, and I should have done it before I started the last time. So we got it all indicated back in, fastened back down, and we're ready to go. Alright, so we got a speed set. By moving it allow, I might can get all my tools in like I wanted to. So. I'm just going to feed it by hand. through one side of it. And then so now we're going to go with a 7/8 and see what we can do with it. Guys, so we're up to, this is probably our last drill here. It's the last straight shake drill I got that will go through both parts. So after this we'll have to start boring it. So let's see what we can get this one through.